going to multiply matrices, your initial steps. Why is that? Your initial step, I would encourage you all to do two things. Even though the question does not say to do it, but I would encourage you all to do two things. First, determine if multiplication is possible. And second, determine the size of the product. Because when you multiply, you're going to get a product. When you add, you're going to get a sum, right? When you subtract, you're going to get a difference. When you divide, you're going to get a quotient. And when you multiply, you're going to get a product. How are you going to determine if multiplication is possible?
By checking the rows and the columns.
Ah,
Yeah, make sure they have the same elements.
keep that thought, keep that thought, keep that thought.
So I know
Huh?
when they have the same row and column.
Right, but that's not how the way I normally communicate it, because you see, as you said there, it kind of remains vague, and I've tested already, and I prefer what I'm going to do there. I prefer do it that way. You count the number of elements in the row of the first. You count the number of elements in the row of the first. Everybody understand that, right? Everybody know
Yes,
to
sir.
count. Everybody know to count, and everybody know what I mean by row and what I mean by first. We're reading from left to right, right? Yes, left to right. So the first matrix there will be the -3 and the 8, isn't that so? And the second matrix is the -5 and the -10. The next thing you do, you count the number of elements in the column, okay, in the column of the second. Okay, you count the number of elements in the column of the second. So please bear that in mind. Row of the first, column of the second. So anytime you see you multiplying matrices, associate the word row with first and associate the word column with what? Second.
Ahmed,
Okay?
sir,
Yes.
I know
Say that again?
the other way around where I heard it go.
You see what I mean? That is why now I doesn't really communicate it that way, because it kind of, it's kind of vague, and then I rather do it that way. Once you do it that way, you save. Count the number of elements in the row of the first. All right. Make sure the elements you count in. Don't count row. Don't count element. Don't count columns. I don't propose to count columns and elements and rows. Kind of confusing. Count the elements in the. If equal, then you come. If equal, then you compare. If equal, yes. If not, no. Simple as that. So I doesn't propose to count rows and element and columns. I'm proposing to count the elements. Okay. Now, determine the size. of the product. The product will have the same number of rows of the first. And it will have the same number of columns of the second. Okay. That's why I say this is my whiteboard here, because right. And make sure you download this, take this with you, save that in a folder somewhere. You see how my folders will, organize. Make sure you organize your folders for posterity, for 115, and then for future university. Okay, because you're building up like your own virtual library, if you want to put it that way. So now the product will have the same number. Now we're talking about number. Now you can count the rows and the columns. So when you're talking about the size of the product, then you want to count the number of rows of the first and number of columns of the second. So for example, in our case, yes, let's go to our own. Let me just increase the, right, let's go to our own. So I'm going to put a therefore. Now the question did not say that, it just tell you to evaluate, presuming that it can, but I would always recommend to determine whether or not. So our first observation, what can I write there? You can write the what? The first what? Starting with M. M-A.
Matrix.
The first matrix, continue. Or you can put, instead of putting the first, what I can put there, the row of the what?
First matrix.
Continue. Starting with H. H-A. The row of the first matrix
So have yeah.
As what? There is say count the number of elements in the row of the first.
2 elements.
The same number of.
Right, the row of the first matrix has 2 elements.
The same number. Oh.
Yeah, you can be explicit. What else can we write? The what?
Column.
The column
Of the second.
The column of the second matrix.
Second matrix has 2 elements.
And someone said the same, right? Has 2 elements. Hence what?
Hence it will be a 2 on 2.
No. We determine if multiplication is possible. We're still on the first point. Keep that thought, but we're still on the first point. We're determining if multiplication is possible. That's what we determine. So hence what? Yes or no?
Hence multiplication is possible.
All right. Hence elements. Yes. You don't have to write yes, but hell yes, multiplication is possible. Once the two numbers are equal, multiplication is possible. Now we can talk about what size will be our product. What size will be our product? How do we determine the size of the product? There it is.
So looking
Yes.
so the row and the column.
So matrix one is a 1 by 2.
No. Try not to say it like that. You can get confused. Try not to say it like that. Look there we have it. The product will have the same number of row as the first, and so you count. Okay, let me write it down. The first matrix has, continue.
2 numbers. But yeah, you already put that.
Look it there, look it there. The product will have the same number of rows of the first, same number of columns. So the first matrix has what?
The first matrix has 1 row.
The first matrix has 1 row. Now, if you're comfortable doing it another way, fine, But for a person that just picking this up, I rather do it that way. And then once you can pick it up, then you can diversify in another way. But for precaution purposes, I recommend that's what you do it. All right. So yeah, so we have to go to another. Let me just put this smaller a little bit. That's notes. That can come smaller. That can come smaller. I don't want to go on another page yet. Right. The first matrix has what? Has 1 row. Okay. The first matrix has 1 row. Under what? Under
The second matrix has 1 column.
the second matrix has 1 column. The first matrix has 1 row. And the second matrix has 1 column. Therefore, the product is a what?
The product is a 1 by 1.
A 1 by 1. A 1 by 1, trust me. A 1 by 1. That's what I promoting how to do it. So if you want, you can read what the unit saying and try to do it that way, but that is the way I promote it. Therefore, the product is a 1 by 1. You can even write it in terms of words. I wouldn't penalize you, but 1 by 1. The product is a 1 by 1.